Hi everyone, in this video clip, I am going to show you another way to solve this permutation and combination question. So if you have not seen the original method, you can click to the link at the description box and find out, see which method is suitable to you. Now over here, let's understand the question again. So we have 7 letter codes. 7 letter cards in which we need to select 5 cards to form a code. And in that 5 letter code, it must contain at least 3 consonants and they have to be side by side. So we have to find the probability of it. So let's write down the requirement of the question. That is the PA. All right, and according to the formula of probability, it will be the number of the event A that occurs out of the total sample. Okay, whereby we define A to be the event of forming 5-letter code with at least 3 consonants that is which are arranged side by side. So this is the event that we are looking at. Okay, so we got to find out how many ways that we can form these 5-letter codes with at least 3 consonants. Okay, before that, we can find the NS. That means the total outcome. The total outcome basically, it is all the 5-letter codes that we can form without any restriction. That means we have 7 letters. We will have 7 choices to be filled in the first empty space, followed by 6 choices and 5 choices for the third empty space, 4 choices, and followed by 3 choices. So we just need to multiply this because these are the different ways for the codes to be formed. So we will have 7 times 6 times 5 times 4 and times 3. All in all, we can get 2,520. And notice that you can also straight away use the formula, which is 7 letters. We take out 5 to permute them. Okay, it's either you use this formula or you use fill in the blank method. So we have the number of total outcome. Next, let's look at the how many possible ways that we can form the 5-letter codes with at least 3 consonants. So when we have at least 3 consonants, that means minimum 3 C, okay, and 2 vowels, whereby these 3 consonants, it has to be formed side by side. Okay, this is the first case scenario. And then the second case scenario is we have 4 consonants and 1 vowels, whereby only 3 consonants are arranged side by side. Okay, because it say at least 3 consonants arranged side by side. So we may have 4 consonants, but only 3 that are arranged side by side. So in this case, V has to be in the middle. Okay, and then another C will be on the other side. All right, why? Okay, let me show you the third scenario. The third scenario also the same scenario as in case number 2, whereby we have 4 consonants and 1 vowels, but these 4 consonants, they are always together. So in order for us to differentiate case number 2 and number 3, the case number 2, C, can never be beside the 3 consonant group. Otherwise, it will be the same scenario as case number 3. Okay, so in case number 2, V must separate these 2 group of consonants. So let's figure out how many ways are there to form the 5-letter codes based on this 3 case scenario. Now, in the previous video, the method we use is we select first, we choose first, and then form a team, form another group, and then from that group we permute. There is another way whereby we can straight away use the permutation. That means to take 3C we just need to permute the 3 consonant out of the 4 consonant. So 4P3 and followed by 3 vowels. We just need to choose 2 vowels to arrange in this way. Okay, that is when our 3 consonant group located in the first space. And then this thing will happen when the 3 consonant group may change the position from the first position, swap to the second position, swap to the last position. So for this arrangement, it can happen 3 different ways. So times 3. Okay, so if you use the calculator, and then you will get 432. Okay, ada bacanya. So we have 4P3 times 3P2, and then we times 3. Yeah, 432. And the second scenario will be the same thing, but in this case, we have to select the 3 consonant first. That means out of the 4 consonant, we just need to take 3 to permute them side by side, followed by 3 consonant, 3 vowels. We permute it in this place, all right? And then left with 1 consonant that we got to 1P1 to arrange them. That is for this case, okay? And the only changes for this second scenario is the 2 groups of C, they can swap place. So that makes another 2 ways of such arrangement. So with this, 4P3 times 3P1, and then times 1P1, which is always 1, and then times 2 times that this arrangement will happen. That will be 144. So the last case scenario will be the 4 consonant, we take all and permute them in this position, 4P4, followed by 3 consonant, we just need to permute 1, okay? And as for this position, these two items, okay, can swap place. So this thing will happen twice. So we take 4P4 times with the 3P1, and then we times 4. We times 2. Okay, we get 144 as well. Therefore, the event A to occur will be either first case scenario or second case scenario or the case scenario. So for each ways, we just need to add up. It will give us the total outcome for A to occur. That will be 720. So the probability for A to occur will be NA, which is 720, over NS, which is 2520. And use the calculator to simplify. We get 2 out of 7. Okay, that's it. So this one, you have to you use the permutation right away, and next, the last step will be you have to think of how many ways that such arrangement can occur for this team to swap from the first position to second position to third position. And for the second scenario, the team of the 3 consonant group have to swap from the first position to the last position. So 2 ways that this thing will happen. And then for the last case scenario, for this 4 consonant group, it can either be the front or at the back. So 2 ways. Okay, so after the normal permutation, we just times how many ways that it can occur. Okay, so that's it for this video. Should you have any question, just leave your question in the comment area. I'll come back to you as soon as possible. Okay, thank you very much.